Chapter 1 Light An Introduction 1.1 Light travels in straight line. Light is a kind of wave called electromagnetic wave, which consists of a pair of varying electric and magnetic field. There are 7 different kinds of electromagnetic waves. They are radio wave, microwave, infrared, visible light, ultraviolet, X-rays, and gamma rays. Different kinds of waves are different in their frequencies and wavelengths, and visible light is just a small part of this big family, so-called electromagnetic spectrum. The wavelength of light is about 400 nanometers to 700 nanometers, where 1 nanometer means 0.000000001 meter, which is very short indeed. So how thick is your hair in nanometers? Ask your teacher how you may measure the diameter of your hair in the coming lesson. Different colors of light also have different wavelengths. The wavelength of violet is the shortest, only 400 nanometers, and that of red light is the longest, 700 nanometers. But remember, even 700 nanometers is still very short. You must have learned that light travels in straight lines. But how can we prove that? Sharp edges of shadows show that light travels in straight line. In school laboratory, on the other hand, the following setup is usually used. There are 3 cards, A, B, and C. These cards are opaque. That means they are not transparent. So light cannot pass through them. Light can only pass through the holes at their centers. First, align the cards so that the cards are collinear, so that the holes lie on a straight line. Then check if you can see the flame of the candle at the other end. Next, move card B to one side, left, right, forward, or backward. What happens when card B is moved sideways? In this setup, we use a laser to replace the candle. When the holes are collinear, the laser can pass through all the holes. We show you that the holes are in the same straight line using a piece of wire. Now, the middle hole is moved sideways. What happened? And what are the functions or uses of the cards A, B, and C? Card A and C are fixed. We don't move them. These cards restrict the path of the light ray, and so they define the direction of travel of the light ray. We move the card B sideways to block the light. Card B shows that light can only travel in a straight line, at least between card A and C, right? 1.2 Reflection and Refraction. A brief and qualitative introduction. Light may perform reflection, refraction, as well as other wave phenomena. The reflections by the glass walls of many Hong Kong buildings form clear images of the surroundings. 1.2.1 Reflection by curved surface. You should have seen surveillance mirror in a car park or in a supermarket. They are convex mirrors. A spoon, on the other hand, has both a convex and a concave surface. They are curved surfaces that also reflect light and produce images. You can see that images formed by different mirrors are rather different. Some are erect, which means upright, while some are inverted, which means upside down. Some are magnified, which means larger than the object, while some are diminished, which means smaller than the object. And sometimes, image may even have the same size as the object. Let's check the following pictures and find the natures of their images. On the left, it is a concave mirror. The image is... Let's talk about the size first. Same size as the object. And what about the direction? The image is upside down, and so it is inverted. In the middle, it is a concave mirror. Let's talk about their size first. So the image is magnified. And what about the direction? It has the right side up, and so it is erect. On the right, it is a convex mirror. Let's compare the image with the object. First of all, the size. The image is smaller than the object, and so it is diminished. And what about the direction? The right side up, so it is erect. Curved reflecting surface can be useful, but it can also be problematic. In London, the Raphael Vignoli's walkie-talkie tower has a concave shape. A car parked in the street is melted by the intense heat from the sun when the building reflects the light and converges onto his car. Difficult to imagine what has happened, right? Watch the video below. 1.2.2 Refraction. A mirror reflects light, while a lens refracts light. Light refracts because there is a change in the speed of light in different media. In vacuum, all colors of light travels at 300 million meters per second, but becomes about 200 million meters per second in glass. That's why when light travels from air to glass, light changes in direction, and we call it refraction of light. Moreover, different colors of light travel at slightly different speeds in glass, and so they are refracted differently. And thus a light spectrum is formed. Different kinds of lens reflect light differently and produce different images. We will study this in Chapter 5. Nevertheless, you should be able to tell the nature of the images formed by a lens. Yes, the image is magnified and erect. 1.3 How fast is the speed of light? The speed of light is very fast. Indeed, there is nothing that can travel faster than light does. And what's more, the speed of light in vacuum never changes. And because of that, Albert Einstein developed his theory of relativity. You also want to find the speed of light? Try this at home. 1.3.1 What is light year? Light year is a distance. It is the distance traveled by light in 1 year time. Now, light travels at 3 times 10 to the power 8 meters per second, which is 300 million meters per second. So in 1 year, it travels 3 times 10 to the power 8 multiply with the number of seconds in 1 year, which is 365.25, multiply with 24, multiply with 60, and multiply with 60 again, which is a very long distance. The radius of the Earth is just 6,370 kilometers. Hence, light can travel approximately 7.5 times around the Earth in just 1 second. And how many times light may go around the Earth in 1 year? So, light year is a huge distance. It is usually used to measure the separation between two celestial objects only. To measure shorter but still a long distance, astronomers also use light second or light minute. For example, the Earth to Sun distance is 8 light minutes, while the Earth to Moon distance is 1.29 light seconds. So 1 light second is the distance traveled by light in 1 second, while 1 light minute is the distance traveled by light in 1 minute. Use a calculator, try to find out how long each of them represents. 1.4 Colors and laser. 1.4.1 Colors. On page 10, you have learned that sunlight can be refracted into a light spectrum, which shows all colors of light. And on page 6, we know that different colors of light have different wavelengths. However, due to the structure of retina in our eye, adding different colors of light together may produce another color of light. For example, blue and red light combine to produce magenta or violet. Mixed blue and green light will produce cyan, which is light blue. Red and green light mixed to produce yellow light. And mixing blue, red, and green light will give white light. These colors of light, namely red, blue, and green, are called primary colors of light because our retina have 3 types of light-sensitive sensory cells called cones to detect these 3 different colors of light respectively. 1.4.2 Laser. Laser beam is also a light beam, but it is very strong and hence usually very powerful. A laser beam usually has a single color of light only. It turns out that laser is always very strong and highly focused. So a laser can travel a long distance before it becomes weak and invisible. Nowadays, lasers are very common and cheap. You must be very careful when you handle a laser source. A strong laser can easily ignite combustible materials, and hence there is a fire risk. Also, never direct a laser to someone. Strong laser can burn the retina and result in loss of sight. That is the end of the chapter. Thank you.